And we're live. Okay, we're just going to finish off some of the notes. Ooh. 1 second. Nope, I want. Where's the view?
Julia, what's your favorite candy? Do you like wine gum? Wow. Ted was Snow last time was his favorite candy. And no, I don't know why, but I think I've seen him eating wine gums before, so I said wine gum. So
I think I know why. Because we bought it, and like me and Christian were like harassing him for candy.
Christian, my boy Christian.
I was gonna say jelly. Oh.
Oh my.
Where's my mom? You know those like the jelly things, little things, the cups. Yeah.
Can I finish 1 second?
Well,
Where can I find Should I pull up
we
children?
will be going for the
I was asked by Coach Lee first.
For what?
I can't find my other binder.
No, today.
Okay,
bomb.
move that up.
I'm making my food.
Squash good.
Last day. We did most of the famous families. Alkaline metals, noble gases, halogens, alkaline earth metals, reactive, reacts with wax. Oh, we forgot a couple of things. In solution, what kind of solution does alkali metals make with water? No. What kind of solution? A hint would be what color it went after I added phenolphthalein. So what kind of solution is it?
Space.
Base. So it forms basic solutions in water. And that's where the word alkali comes from. Alkali means basic. And alkaline earth metals basic solutions. Also in water. That's why they're alkaline. And it has 1 electron in the valence shell. So what kind of, it forms +2 cations. Oh, we missed it off of here. What kind of cations will the alkaline earth metals form? +2. And then as we go across, so these ones are basic alkali metals, alkaline earth metals, and then these ones no longer really form basic solutions, so they're just known as the earth metals. Carbon group, nitrogen group, oxygen group, or tetrals, pnictogens, and chalcogens, and then halogens. I don't actually know the proper pronunciation of chalcogens. I haven't looked it up. And I keep forgetting to every time I think of it. But it could be chalcogens for all I know. Finish off there. Oops. I have something out in the lab.
And he's gone.
I'm organizing my like I have a backup.
We might have to do the demo of the classroom if they're out there. Okay, so that was the metals, halogens, and then there's the last one. In one sense, the saddest one. Unique among the elements, hydrogen. It is its own family. How many electrons in its valence shell? One electron. And that's like the alkali. How many electrons does it take to fill its shell? One. So it doesn't really belong in either one of those. You'll actually see periodic tables that sort of will put it hovering above either the halogens or the alkali metals or both. What kind of ions does it form? Yep. Plus one and minus one. So we can get hydrogen plus one, which is acid, or we can get hydrogen minus one. We call that the hydride ion. It's a little bit more uncommon, but it does occur often enough. Oh, that plus one looks like an H. Fix that up. And so hydrogen is like the saddest person to walk into a restaurant, you know? Party of one.
Did you say hydride?
Hydride. Yes.
Wouldn't the carbon family also do the same thing in different ions?
Because it's plus 4 and minus 4, they can do both, but they don't have all the unique properties of hydrogen, and they also have other members of their family. There's selenium and underneath carbon.
Yeah.
Sorry, not selenium, silicon, germanium, and they share some of the same properties. There is nothing quite as unique as hydrogen. It, you could say, bears some similarity with the carbon group, and then it's halfway, but it's just one electron away, or from either going out either side. It is also the most abundant element in the universe. If you ask me what is up, I will say monoatomic hydrogen, because no matter which direction you go, eventually you'll be in interstellar space where the hydrogen is so far apart that there's just one atom of hydrogen with one electron, monoatomic hydrogen, and then other nearest hydrogen is hundreds of kilometers away, and that is all of space, drifting forever, lonely and sad. Although sometimes they get attracted, really excited, and they form entire solar systems because that's what makes up the sun. So, most abundant element, unique amongst all the other elements, its own family, hydrogen.
What's up?
What's monoatomic hydrogen? The transition metals, I don't think we've labeled those. So the transition metals are here. And I'm not going to spend too much time on them other than to say that's just what that area is called. So if someone says we're doing with the transition metals, that's in there. But it does bring me to why the periodic table is drawn in this kind of an odd way. We're repeating properties, so lithium is like sodium and beryllium is like magnesium. And then it wouldn't make sense to put boron here because it's like aluminum, gallium, so we start spreading things out. But then we also do things because publishers don't like things. So if you look at a periodic table, which is not the one I have on the board, you will find you have this. Let me make that more appropriate to the size. There we go. And then we have that one there. Close enough. And we have a periodic table. It goes through. And then, does anybody know what these ones are called? Yes. Lanthanides and actinides, if you're talking about the rows. But in the same way that these are the transition elements, those are the inner transition elements. And why are they down below? Yeah.
Just make the periodic table way too wide.
Well, there's no such thing as way too wide. It just irritates publishers. We could do that. Just turn your book sideways. And you can find it that way in some areas. But yeah, it's purely a publishing reason. The real quote-unquote periodic table should look like this. Will I even fit it on? Oh yeah, it'll just work. There we go. So we have alkaline metals, alkaline earth, inner transition metals. Or, as you said, the lanthanides and actinides. Oh, hold it. We're literally missing lanthanide and actinide on my model. I think I accidentally cut them off because 57 and 89 are missing. And then it stretches out. That's the actual periodic table, and that shows the repeating properties. But because we want to save space, we put it down below. And I want to show that solely for the same reason that I have. At least they said it was true. I don't know whether to believe them, but Americans who said they thought Alaska literally existed below the U.S., floating in the ocean like an island, because that's the way it's drawn on their maps. They don't show it attached to Canada all the time. And so if you don't show it the way it really is, maybe some people think it really does float down here for some weird reason. It does not. Although I don't know, maybe they were just making that up to seem funny. So, transition metals, groups 3 to 12, their valence shell is varied. I'm not going to worry about them too much. However, the boron group, or the earth metals, how many electrons in its valence shell? 3.
Yo, boy, please stop fighting.
Carbon group, or tetrals, how many electrons in its valence shell? 4. And the nitrogen group, or pnictogens, how many in its valence shell? And the oxygen group? 6. Which gives our pattern what kind of charge? So that's the valence electrons. I'm going to put the charge on this side. What kind of charge is the boron group going to have? Positive 3. Carbon group? Positive 4 or minus 4? Negative 3. And last one? And so we can see the pattern there. We also see that reversal of pattern, positive, positive, in between, negative, negative. If you take chemistry next year, you'll notice that is a very common theme in trends and where it sort of switches on the staircase line. When we talk about metals and nonmetals, metal is just a convenient term that we use to distinguish properties. Different pressures and temperatures can lead to other things having metallic properties. In fact, hydrogen itself was once believed and may be possible that at the center of Jupiter it is compressed so tightly under high pressures that it becomes something called metallic hydrogen. And metal just means shiny, conducts electricity, malleable, has those particular properties. So this staircase line could move a little. However, francium is the most metallic because it most wants to give up its electrons. As you go down, it gets bigger, and so it's easier to let go when things are far away. On this side, when you're trying to fill it in, as you go down, as you get farther away, they get harder and harder to attract. So for the exact same reason, you get two opposite reactivities on the other sides of the periodic table. Okay, we are, I think, officially done. I have one more demo, and in this demo, I'm going to ask you to explain what happened. They're out there, irritatingly. I could bring it in here.
Yeah.
I will. What I'll do is I will do it. Yeah, that'll work. Okay. Get out a piece of paper, something to take notes on. You'll want to make a couple of observations. I will grab. There we go. Matches. How many matches do I have left? I have about 2 matches left. gonna turn off the lights. So I have a Pringles can. Are you taking notes on your iPad?
Yes.
Perhaps go back one day.
Okay. Is that the?
And maybe, just be a
Oh no.
more covering of the screen.
Is it okay to take?
Oh.
Okay. For this particular demo, sound plays an important part of it, so you will need to be quiet. Those in the back, do you hear it? Keep listening. It has started.
It's ready to pop.
Now, in terms of explaining,
Cool.
now, it was pure hydrogen gas. In the test tube, what does hydrogen gas go when you light it? Oh, it goes squeaky pop, squeaky pop. When we did the balloon of hydrogen, it just went whoosh. It didn't really even go bang. That went bang. But first it whistled. All this is a Pringles can. It's completely empty. I filled it up with hydrogen gas. This has a hole at this end. So the hole was here, resting on a triangle, just hold it up. And then on the top there's a pinhole, which is what I lit, so there was a small flame. I don't know if you noticed, right when I lit. And so that flame was just being fed hydrogen the whole time. And then gradually the whistling sound got louder and louder and louder. And then as you witnessed, there was rather a bit more than a squeaky pop. Well, I'm not going to answer. This is your last question in chemistry. Yes?
What that was for the Zeppelin thing, for like the Hindenburg incident. It was also using hydrogen gas, right?
Yeah.
Yeah, that made them explode.
Well, they didn't explode either.
Well.
In fact, it took so long for it to go off. They actually got, I think, everybody off of the Hindenburg because it burned, but it didn't go bang.
Yeah.
So
I think
reuse. So I am. You don't have to write it necessarily on a Google Doc. I have made a question on the Google Classroom. You can reply to each other if you want to work together in some particular way. I would like your explanation using all of your chemistry knowledge. Why did it happen that way? Why is there a bang? Why is there a squeak? Why did it take so long? What was going on?
Is this great?
Yeah, we've had
Everything in your life is graded. The test started the day you were born. It ends on the last day. Don't.
Is this for marks?
Yeah, so then when that there's a view.
I don't even know.
I always hesitate because
Is that you?
everything's data. Everything's data. At some point in the year, maybe I'll be
Is that
picking
you?
between, who wins the chemistry award and who doesn't. Maybe I'll be picking between this person has a good explanation. Do I bump them to an A or keep them at a B because they're at 85%? This person makes loud noises when they sharpen their pencil. Mark one down. Nomenclature. That was a nomenclature. Nomenclature.
What was the gas that you added?
Pure hydrogen gas. That is one of my favorite.
Squeak pop, why?
What's like a more innate explanation of what we just
So it's Kringle Cat.
Hold on, let me log into a certain website.
What?
Will help.
Let's talk about Oliver. And what do you think?
I don't even know. You know?
Okay, what
So
is it?
what's
We
it? He knows a whole part of it.
Say,
or
come on, bro.
So
Please
I'm
send
so
it.
info.
That's what I like.
So he
There's info. Or
Means
there's a whole
You
nother.
build a whole about it?
Yeah.
no he, when you build Kringle cat with hydrogen with one atom.
Wait, there was what?
Yeah, 'cause
Wait,
oxygen-
what do you mean? There was a whole cover or no?
We build this
Is oxygen's heavy than hydrogen, right?
Yeah, was it fire?
Hydrogen's lighter than oxygen.
I think that's maybe sounds like hydrogen gas.
So in the like if you push the bottom, but heat the hydrogen.
I think it's. I feel like you might be right. That seems
No. He's distracted already. No. Although foiled by window.
Oh my goodness.
As you are answering, I'm going to hand out so you can just have a look what we're going to be doing next day. As I said, your chemistry is done. You now have biology,
I love biology.
DNA, although that would be an inappropriate subject. My apologies. Monty Python is rarely appropriate, but always.
But a lot
Pardon?
of biology.
Oh, it's fantastic, but it is not appropriate to be sung in the middle of a lecture. If you do see the meaning of life.
Oh, that's a good one.
Pardon?
Be alive
What?
is good.
Yeah.
What's this?
That's your next set of notes. That is half our unit 2. Oh, listen. But there's lots of diagrams and stuff, like lots of diagrams.
Oh,
Like
I
lots.
This is so many. Okay, very stupid question. How did you get
Yeah,
that
exactly.
concept? You stupid answer.
We have problems talking about these.
Right, you're what?
I got it years away. I'll see the same reaction. Does it get a squeak?
Oh, the program will be tomorrow.
Oh, yes. That's the same reaction. Okay, the reason it's not smaller scale, smaller can, although to be honest, only half, not that much smaller. Also, he didn't know. The important point, I put mine in a triangle and lifted it up. He didn't, flat on the ground. That may have made a big difference.
Yeah, I also have a slow mo.
Oh,
Which kind of causes
Yeah.
you to fly underneath. Into
oh, here's more. Who else doesn't have biology? This is my biology. Here's biology. Here's biology.
We can figure it out.
Oh, cool. Yeah. Give you one.
Okay, so I'm like this.
Pablo.
Thanks.
Two.
Why is he so short?
Why is it so short? Don't worry, it's only part one of unit two. Yeah.
I was concerned.
Yeah.
Why do you still need anything here?
What?
It's just all the chemistry stuff.
Yes. In this, you have a final exam on the year.
Pablo Barroso.
Wait, can I like get rid of all of these, put it in like, keep it in one place? and-
You could put it in another binder and put it on your shelf for the moment. Now, what are you going to have next week in your last assessment on chemistry? Did I tell you last thing? Yeah. So you'll get a quiz on your lab. You will have your lab book for the quiz, which you'll get back in early next week.
That's easy.
And then next class you'll have like a quiz or a test. And that will be your last assessment. You'll do chemistry, and we're also going to start biology next week.
Oh, Andrew.
What?
Julian Chan.
The lab.
Let's see your answer here.
But you'll get your
Think
book
there was
ahead of time,
sound for the
your lab
prompt,
book,
a little hole
and the
in
quiz will be open
The
lab
hydrogen
book.
gas slowly
We don't need to
fire
study
comes with specific gas.
If you have done the lab and you can answer the questions, you'll be good.
Oh, I've asked the questions.
But you'll get it
That is
ahead of
Julian
time. You can
Chan's
answer it
answer.
after the lab.
So yo, read Pablo's question. Oh, weird cat. The big
Yeah.
the big
Yeah. No, it's stuff. And
Pretty cool. That's pretty cool.
Pablo,
Easy.
thank you for coming to class.
Oh yeah, it's because they think you have to do and you have like
What?
I told them I
I'm
knew
gonna
then
reverse
this
this
I
and
could do it.
analyze it.
I was gonna do it.
Wait.
Wait,
No,
wait,
that's
you mind? I
all
think.
the options.
Bro, we
No,
should, bro, we
it's
should
up-
do score.
it's-
Wait,
no,
Look
the
how
flame-
cold that would
Wait,
be.
Okay,
how
it
many
needs
more?
oxygen. No, it needs oxygen.
Oh, I just
think
pulled up
it's
some
air.
air.
So it's on the
We need some
triangle.
sort
It
of
needs to be
secret.
elevated to get enough
Yeah.
oxygen,
He said
which
instead
feeds
of
the flame, which is activation energy, create the bond, like synthesis,
like you
oxygen,
hydrogen
what's it?
LRP.
Increase water.
Yeah, oxygen hydroxide, or which is hydroxide.
The supponents
Makes
I just
explosion.
Oh,
It's excellent.
bro, why did you ask? We asked Mr. Brandstar, and he's like, he let us go watch the volleyball. Mr. Brandstar.
What do we do once we're done?
Hmm?
What do we do once we're done?
Read through your biology.
Yeah.
What?
Oh,